Okay, so let's talk about how soils form. Soils are things that a lot of people don't appreciate as much as they should. We can't have life, terrestrial life at least, life on land without soils because all the vascular plants on land depend on soils. And soils are a living, breathing part of our environment. They're not just dirt. So let's just give them some respect, can we? And let's just talk about it. So here's what soil does in terms of ecosystem services. So it stores a lot of water, which is available to both humans and plants, most specifically plants. It purifies and cleans water as it infiltrates into the groundwater. It cycles nutrients, especially nitrogen and phosphorus. And without it, plants can't grow. And if there's no plants, there's no food web. So yay, soils. Now, basically, soils are a reservoir of water. There's an enormous amount of the world's fresh water is caught up in soils, and that is available to plants long after it rains. So if soils didn't retain water, plants would only live while it was raining, then they would die. And mostly they're able to do this because of the smaller particles that are present in it, mostly clays and silts that allow it to do that. And it's worth noting that there's more water in soils than there is in all of the rivers and lakes in the world. So they're really important soils because they are essential for root growth. And without root growth, we can't have land plants and we can't have life on land. So it provides both a structure for the roots, the plants to hold themselves up, and it also provides water for photosynthesis. So a healthy soil is not just this static piece of mineral dirt. It's full of living, breathing things, right? So it's got all these decomposers in it, like worms and arthropods, like millipedes, centipedes, and other kind of bugs. And these things help return carbon and nitrogen and phosphorus to the soil. It also contains a lot of bacteria that we talked about earlier in the year. They're responsible, especially for the nitrogen cycle and other aspects of the ecosystem. And there's a lot of decomposing matter in the upper parts of soil where plant matter falls in and you have that ammonification happening. And that turns out to be a tremendous amount of the world's carbon budget. So apart from the oceans, the biggest carbon sink on the planet is actually the world's soils. Soils are a really important thing, and they are things that humans, if we don't manage correctly, we can lose. We've lost a lot of them. Now, one of the most important things about soil is what's called porosity and permeability. So pores are the spaces between mineral particles. So you got these mineral particles that make up the soil, and you've got these pore spaces in between them. And these pores are filled with both air and water that adheres to the surface of the mineral grains. And that's important because when plants grow in here, they need to get the water off the surfaces of these mineral grains for photosynthesis. But roots, they have to respire, they have to breathe. So here's their source of oxygen for breathing purposes. So if you don't have these pores, then you don't have plants. Now, clay is a really important part of soils. Clay is this very, very small kind of mineral particle. We'll talk about it in a bit. But what's really important about it is it has the surface has a negative charge, and it tends to attract positive ions to it. And what that does essentially is it allows their presence, the presence of soils, tends to clean out impurities that might be present in water that filters into the ground, including some certain toxins and certain heavy metals. So essentially, what this means is soil is this big filtering system that provides this really important ecosystem service of cleaning water that infiltrates so that when it gets into the ground and then flows out into rivers, it has been cleaned. So it's this big purification factory, if you will, for water. So how exactly does it form? We talked about this when we talked about primary succession. It's a long process. It can take hundreds to thousands of years. And so what happens is basically you have rock. The rock has to basically start to break apart into smaller pieces. Eventually it starts to accumulate a layer of organic matter from dead lichens and mosses and things like that. And after a while, what was rock breaks down through the process we'll talk about in a minute. And we have these mineral particles that then become intermixed with the organic material above it. And eventually this gets deeper and deeper and deeper. So this happens by both mechanical processes, like physical processes that tear the minerals apart, but also by chemical processes that alter the rock material and turn it into other materials, namely clays. So let's first talk about the mechanical processes. So the mechanical processes by which bedrock, solid rock, is broken into smaller particles that make up soil. It comes from temperature changes. When it gets hot, it expands. When it gets cold, it contracts. It makes for cracks in the rocks. Into those cracks, sometimes water gets, and so in areas on the planet where it freezes, ice wedging is a great way of breaking the rock apart because you might have noticed if you ever left a soda in the freezer, water expands when it freezes, and that further accelerates this process. Roots grow into rocks, and as they swell and expand, they are able to break up rock into smaller pieces. And then abrasion, just the mechanical movement of water and wind, can cause these larger particles to become smaller particles. Now, we sort these particles out by size. Okay, so we basically have four components, but in soil, we're really going to concern ourselves with three. So by size, what we have is gravel, which is fairly large, about 2 millimeters. Then we have sand, which is about 1 millimeter across. We have silt, which is considerably smaller, and then we have clay that you couldn't even see at this level here. And these three right here, sand, silt, and clay, are the main ones we're going to focus on in this unit. Now, chemical weathering is basically when water gets into, soaks into rock material. It tends to be slightly acidic because it picks up carbon dioxide from the atmosphere, forming carbonic acid. So the pH of rainwater is naturally a little bit low, acidic, and that tends to react with certain minerals, especially feldspars, turn them into clay minerals, which then not really dissolve, but they liberate themselves and move into the soil. So clays usually come as a result of chemical weathering of other minerals that were present. So the process of this occurring, of taking bedrock into soil, is a very long process, right? It can take hundreds of years to thousands of years. And because of that, we need to think like soil. Without soil, there's no plants. And without plants, there's no people or anything else on land. So soils are vitally important. And we need to think of them as a non-renewable resource. We can't make more soils. Soils take too long. The time it takes to make them is beyond the scale of human existence, at least of a lifespan. Okay. Now we're going to break soils into different horizons. And yes, you do have to know these horizons for the test. You'll probably get at least one question about this. So soil horizons basically, we'll talk about them, but there's basically the O, the A is not here, but there's the E, the B, the C, and the R. We'll talk about them. But there's different layers that have specific characteristics about them. And so a soil profile is basically an assessment of the relative thickness and presence of absence of these different soil horizons. So we got to learn this. Okay, this is one of those things, unfortunately, you got to memorize. Okay, so basically, here you go. You have the top layer is called humus or organic. So we say O because it's basically leaf litter and other decomposing plant matter. All right. Below that is the A horizon, which is the topsoil. We'll talk about each of these in turns. Below that, we have the E horizon that's been kind of leached of minerals. Below that, we have what's called the B horizon or subsoil. And then below that, we have the C horizon, which is basically the transition zone between bedrock and soil. And then below that, we have the R or the bedrock. Now, how are you going to memorize this? Here's my advice. Look, we have A, B, C. Okay. Those are the three main layers, right? Then above it, we have an organic layer. If you've ever looked at the forest, you see all this organic material sitting on top in the form of fallen leaves and material like that. So it makes sense to have the O horizon for organic on the top. And you just remember the E horizon, which basically means illuviated or leached, is between the A and the E. And just remember the bottom layer is R for rock, okay? So A, B, C, sandwiched between O and R, and we're going to set the E between the A and the B. All right, that's how I remember it. Okay, now let's take them each in turn. The O horizon is basically this dark layer. You've seen it. It's basically very high in organic material, lots of nitrogen and phosphorus in it. It's basically made out of mostly dead plant and to some degree animal matter. We sometimes refer to this as humus, not hummus that you would eat, like not the Middle Eastern treat. But it's very important for plant growth because it contains so many nutrients. The A horizon is also known as topsoil, even though it's actually not the top. Right? It's right below because the humus almost isn't really soil. It doesn't have mineral components to it. Right? It's just decomposed plant matter. But soil containing mineral particles, it starts with the topsoil or the A horizon, and it's got a lot of organic matter that came in from above. It's highly porous because it has a lot of burrowing organisms in it that keep it well aerated, so it tends to drain pretty well. So it's very much alive. Okay, it's where a lot of the bacterial nitrogen fixation such happens. Now the E horizon isn't always present. So the E horizon is just below the A horizon. So here the O horizon is the organic material up here, the humus. Below that we have the topsoil, the A horizon. This is what farmers work with. Below that we have the E horizon. Basically what that means is as rain comes in, it tends to leach materials out of here. And what you're left with is more of the sandy component. So it tends to carry clay minerals and silt minerals and nutrients away. So this horizon tends to be pretty devoid of nutrients and pretty high in sand. And it usually, we see this in older soils. It takes a long time for this to form. So younger soils tend not to have this. The B horizon, which is known as the subsoil. So think of the A as the topsoil, B is the subsoil, and E is that one that kind of gets in there in between. Okay, basically, all the clay and aluminum and iron and nutrients that get leached out of this layer, they end up down in this one here. So it tends to take on this reddish color because it absorbs a lot of the or accumulates a lot of the iron and clay from the E horizon. Below that, we have the sea horizon. The sea horizon, you notice there's rock material because the sea horizon is basically where the bedrock is turning into soil. It's fully soil by the time it gets up to the B horizon, but in the sea horizon, you've got that in between transitional zone between soil and bedrock. And below that, you have the R horizon, which is just pure bedrock. Now, almost done here. So soils are different by biomes. So that shouldn't be too surprising. So let's just quickly go through each biome and talk about its soil properties. Okay, here you go. All right, so the tundra biome, you shouldn't be surprised, has a very thin layer of it's very thin layer of soil. There's not a lot of plant matter there, so there's not a lot of nutrients. It tends to be slightly acidic, and there's that layer of permafrost that really keeps much from happening there. Now, in the taiga, what we find is it tends to be very low in nutrients, primarily because pine needles, when they decompose, they make the soil highly acidic, and that helps leach the nutrients out of the soil. In the temperate seasonal forest or deciduous forest, like what we have here in Korea, there tends to be thick topsoil because we have like a lot of leaves on it, which helps keep that soil there. And it tends to have moderate to high nutrient levels. The reason it's moderate and not very high is simply because there's quite a bit of rain in temperate seasonal forests, and rainwater tends to leach nutrients downwards. Temperate grasslands have the best soils for agricultural purposes, so it's not surprising that humans have destroyed almost every grassland on the planet because they're so rich in nutrients. They have a very deep layer of topsoil, and it's very, very rich in nutrients because of the decomposing grasses. Now, tropical savanna, on the other hand, it may be a grassland. However, it's hotter, right? So it tends to evaporate more, so the soil is drier, and it tends to be lower in nutrients. Now, in the desert, obviously, the soils are very, very poor. They're the worst soils of all. In fact, they're basically almost entirely just mineral. There's not a lot of organic component to it. Also, it's just sand and silt. Very, very low in nutrients. And once a soil has turned into a desert soil, it's really hard to ever get it to come back. Tropical rainforest. I don't know if we talked about this yet this year, but you might be surprised that the topsoil tends to be very thin and low in nutrients. And the reason for this is that you have so much rainfall leaching out these nutrients, and there's so much biotic activity going on that matter that falls to the floor gets put into animals and plants right away. So there's not much to get in the soil. What gets in the soil gets leached out. So very low in nutrients. And then temperate rainforests, they tend to have thick topsoil, and it's fairly high in nutrients because you have a lot of productivity. And so you have a lot of plant matter going into it. But it's unlike the tropical rainforest, you don't have quite as much in terms of organisms taking it out and recycling the plant matter. So it tends to form this layer of topsoil. Okay, that's it. Thanks for watching.